Pre-calculus 9.3, day 1 and 2. And these notes will be due on the first day with day 1 homework. All examples. We are moving to a geometric sequence. We looked at arithmetic sequences in series. Now we are looking at geometric sequences in series. And the geometric sequence is a list of numbers, but how you get from term to term is you multiply by the same ratio, the same number, as you go from term to term. And so if I have my first term being a sub 1, then to get to the next term, I multiply by what we're going to call a common ratio that we're going to use the variable r with. So that second term is going to be a sub 1 times r. So you multiply by r to get to that next term. Then to get to the next term, you multiply by r again. So you get a sub 1, and then that is r squared. And you multiply by r again to get the next term, and so on and so forth. Now we want to see a pattern here, and so you've got your first term, then you have your second term is a sub 1 times r, your third term, a sub 3, is a sub 1 times r squared, your fourth term is a sub 1 times r cubed, so we want to think, what is that general term? What is the pattern for the nth term? And if you notice, the subscript, the term number, the fourth term, you've multiplied by r 3 times. So you've multiplied by r 1 less than the term number. So the general term is your first term, a sub 1, times r to the n minus 1. So if you're out and you want the 100th term, it's going to be a sub 1 r to the 99th. So the nth term of a geometric sequence, a sub n, is a sub 1, your first term, times r to the n minus 1. And how you find r, it's listed right up here, is you take that second term divided by the first term. So you're not subtracting like you do in arithmetic, you are dividing for a geometric to get that common ratio. And since you are multiplying by r, you can get large or small really quickly. It's, if you'll get larger if r is greater than 1, but if r is between 0 and 1, then you can get small really quickly. So, some problems, write the first 5 terms of the geometric sequence. They give you a sub 1 and they give you the common ratio. So, your first term is 5, and then you are multiplying by root 3 to get to the next term. So it is just 5 square roots of 3. We want exact values here. And then if I multiply by square root of 3 again, 5 root 3 times another root 3, you get 5 times 3, so that next term is going to be 15. And then multiply by root 3 again, and you have 15 root 3 is your fourth term. And then you have to multiply by that root 3 again to get to the fifth term, so that's 15 root 3 times root 3. You get 15 times 3, and that is going to be 45. So there are my first 5 terms of the sequence. Get rid of the times 3 here. Clean that up a little bit. And there are my first 5 terms. So then you will be asked to find the 9th term here. When you have the first term is 4 and the common ratio is 1/2, you are not going to get credit for just crunching out numbers. You must show use of the formulas. And typically, you need to come up with the rule, which is your general rule for the nth term. That's what you're going to be asked for on tests. And just remember, a sub n is your first term, a sub 1 times r to the n minus 1. That's what we mean by the general rule. And we know here that a sub 1 is 4 and that r is 1/2. So my general rule for the nth term is going to be 4 and in parentheses 1/2 to the n minus 1. That is not 2 to the n minus 1. That does not work that way. You have to take the powers before you multiply by 4, so you cannot take the 4 times the 1/2 first. So just warning on that. The best you can get is a sub n is 4 times 1/2 to the n minus 1. And now we want the 9th term. So that is when n is 9. So a sub 9 is going to be 4 times 1/2 to the 9 minus 1. So we have 4 times 1/2 to the 8th. And so that is going to be 4 times 1 to the 8th over 2 to the 8th. So you need to show some steps on this. So you get 4 times 1 over 2 to the 8th is 256. And that simplifies the 9th term to 1/64. Give exact values and simplify where possible. Okay, example 3. Find the 6th term of the sequence. Well, you can see that a sub 1 is 2, and to get r, you take that second term divided by the first term. So you have 3/2 divided by 2, which is 3 over 2 times 1/2. It is 3/4. That is your common ratio. And so show use of the formula. So start by finding the general rule. And that is a sub n is a sub 1 r to the n minus 1. So a sub n is going to be 2 times 3/4 to the n minus 1. Again, you cannot simplify the 2 and the 3/4 because you have to take 3/4 to the n minus 1 first. And now we want the 6th term, so that's going to be when n is 6. So a sub 6 is 2 to the 3/4 to the 6 minus 1, or to the 5th. So we have the 6th term is going to be 2 times 3 to the 5th over 4 to the 5th. And so I want an exact value on this, so you need to use your calculator and work on 3 to the 5th is 243. And 4 to the 5th is 1024. And so now you can simplify. 2 goes into 2 once and goes into 1024 512 times, and this becomes 243 over 512. And that is the exact value of a sub 6, and it is simplified. In example 4, find the 6th term in a geometric sequence in which the 3rd term is 10 and the 8th term is 2430, and the common, ratio is positive. Because in geometric sequences, you can get alternating terms, positive, negative, positive, negative. If r is negative, you will get terms that alternate in sign, and that can happen. And on this one, you must show use of formulas, and you must set up a system of equations using the formulas. Without them, you will not get credit. And you're going to be using the formula for the general term. So we are going to use a sub n is a sub 1 r to the n minus 1 for the 3rd term, so where n is 3. So a sub 3 is we don't know the first term. We don't know r, but we know n is 1, and we know the value of a sub 3. A sub 3 is 10, so we can plug in 10 for a sub 3. So I get 10 is equal to a sub 1 r squared for the third term. I'm going to do the same thing now with the eighth term. That's going to be when n is 8. So a sub 8 is, I don't know a sub 1, I don't know r, but n is 8. And I know the value of a sub 8. That is the value of a sub 8. It's 2430. So now these two form my system of equations. I have 10 is a sub 1 r squared, and I have 2430 is a sub 1 r to the 7th. So I have two equations, two variables. I can solve for both of them. So the process is to take this first one and solve for a sub 1. So divide by r squared and solve for a sub 1. And then we are going to substitute that in for a sub 1 in the second equation. And we get 2430 is 10 over r squared times r to the 7th. So I have substituted in that 10 over r squared for a sub 1. And now I can simplify because r squared takes out 2 of those and makes this r to the 5th. And so I have 2430 equals 10r to the 5th. Now I need to solve for r. So divide by 10. You need to isolate the r first, and then take the 5th root of both sides, which will get you r here, and the 5th root of 243 is 3. By the way, you can, on a calculator, the 5th root, you can raise this to the 1/5. That's the same as taking the 5th root. Otherwise, there should be a button, where you can put in the index of 5 for n on your calculator. So make sure that you know how to take the nth root of a number on your calculator. Anyway, so r is 3. Now, I want to find the 6th term, but you have to show use of formulas. And so I want to get the general formula for this. I now know the common ratio, but I still need the first term. And that is the work I want to see. So we need to find the first term, but right here we have that a sub 1 is 10 divided by r squared. So a sub 1 is 10 over 3 squared. A sub 1 is 10/9. So the general term, a sub n, is a sub 1 r to the n minus 1. My a sub 1 is 10/9, and my r is 3. And that is my general term. I should see that in your work as you're working through that. That is the rule you should come up with. Again, number crunching is not going to be accepted as work. You have to show all this that I'm showing. And so now it asks for what is the 6th term. So continuing for the 6th term, when n is 6, I'm going to have a sub 6 is 10/9, and 3 to the 6 minus 1, which is 10/9, 3 to the 5th, and 3 to the 5th is 243. But 9 goes into 243 27 times. and you get a sub 6 is 270. And so you're going to want to know how to set up a system. You will be tested on this and solve for a specific term and doing the process that I just outlined. Those are your notes for day 1 and day 2, which will be due with the day 1 homework.